Hello everyone, in this video I will show you how to set up simulation in ANSYS Explicit Dynamics. So here you can see the workbench and use a version of the workbench ANSYS. In order to start the setup, I need to select Explicit Dynamics. First of all, I need to select engineering data. Here you can see a list of the material that is selected. It's structural steel by the default, and I want to select the other materials. I enter to the engineering data sources and I select among the general materials, general nonlinear materials, explicit materials. For example, general materials. Here's the general materials, general nonlinear materials, the explicit materials. Also other materials, hyperelastic materials, magnetic, thermal. So from these explicit materials, I will select aluminium ceramic. So in order to add, you need to click plus button, and this sign means that it's in the list of material. Then I select titanium aluminium. Also, so here you can see the selected list of materials: aluminium, ceramic, structural steel, and the titanium aluminum. Also, you can see the properties of each material. Here are the properties of the material. Also, additionally, you can select, for example, use this toolbox and add the additional properties. So in our case, I want to add, for example, failure model, failure Johnson's Cook model. Yeah, I select, for example, for the titanium aluminum, you have these values. This one is 0. Different temperatures. Kelvin. So we've selected the material and this select properties. Then you need to import the geometry model. First of all, I created a model in SolidWorks. Here you can see our model. It consists of bullet and the armor. And you need. It's important to save. Import image, browse this one. And, you need to save your assembly model in the parasodic format, .xt format. And in order to save the time of simulation, we can simulate only 1/4 of this model. So I need to open the designer modeler. Here's the design model and the import and generate file. So here you can see our model. And create symmetry. Select two planes. First one is ZX plane. Second one is XY plane. In the generate symmetry, you can see only 1/4 of the model. Here, then I will show you the model part. Here's the model part. And first of all, we need to assign materials from this one for the layer. For the layer, we select titanium alloy, and for the cylinder one is aluminium ceramic. And for bullet is structural steel. Then I need to set up initial velocity for the bullet. Select this the model bullet model, and the simulation part, you can see the remaining time of the simulation. So simulation ended. You can see the solution of the simulation. Can insert what? So for example, the stress. And deformation. And the strain. Evaluate all results. And you can see the result of the simulation. So equivalent stress. Can animate simulation. Here you can see the animation of total deformation. So that's all. If you want to see the more detailed results, you need to play with the materials, with the properties of the materials, set the right properties, right shear stress, Young modulus, and the Jones-Cook model or Jones-Holmquist model. Also make the more fine mesh, and so on.